Yeah, I kind of broke it, and that's pretty much where that ended at that point. What's going on, everyone? It's RZ over here at Bukugames, and I'm here with yet another devlog on Right Place, Right Time, our newest game that's coming to iOS and Android later this year. Last week we didn't really get a devlog out, but we did reveal a new era in the game, which is going to be that of feudal Japan. So if you love that old school feudal Japan style with samurais and ninjas and throwing stars and all that stuff, you're really gonna love this era in our game. So we're really excited to show it. And just as a sort of disclaimer, it is not historically accurate. So if you're looking for a history book with Right Place, Right Time, you're not going to find it there, but we will have some crazy fictional elements that I'm sure a lot of people will enjoy. That being said, we're going to be talking a lot about what goes into creating these eras, what goes into creating different enemies, and a bunch of different things that have to go with all of this. And it's a lot for me to discuss. I have over 3 hours of footage here, and I'm going to try to skim through it and show you guys kind of a reaction to myself failing at coding. I don't know how this works. I have never done reaction stuff. But with that being said, we're going to get right into the video. I'm not going to delay any longer, and let's do it. So before I get into actually reacting to myself coding and all that stuff, I wanted to explain kind of how the enemies, or as we like to call them, obstacles in our game works. So there is something in the programming language we're using called inheritance, and I kind of want to go over what that is just briefly. So for all of you who just want to see me react to myself failing, go ahead and skip to this time in the video. But without further ado, I'm going to kind of explain a bit about what inheritance is and what it's all about. So for those of you that skipped ahead, see you then. For those of you who stayed, let's do it. So the gist of inheritance is essentially what it means. You inherit stuff from your parents. You inherit facial features. You inherit skin color. You inherit a bunch of other things that could be both physical or could be like athletic stuff or skills that you may have. That's how inheritance works in programming as well, specifically object-oriented programming. But yeah, that's pretty much how it works, and the best way that I like to describe it is using the fruit or vegetable analogy. And fruit and vegetable, you can go either way you want with it. I usually just take fruits. So an example of inheritance would be an apple and a banana. Both an apple and a banana are fruits, but they have different characteristics to them. In terms that a gamer would understand, let's say an apple gives you plus 50 health and a shield. Let's say a banana gives you plus 100 health and gives you super speed for like 5 seconds. Now, you could code in, hey, I want to have the apple give me 50 health and give me a shield. I want the banana to give me 100 health and give me the super speed. Or you could have a fruit class, which both of these come from, and you're basically saying anything that's a fruit, I'm going to have that give my player some health. But within that fruit class, I can kind of take that health and modify it. So if I'm an apple, I want to give 50. If I'm a banana, I just change one value and I give 100. And you can give the specific apple class its own shield thing and the specific banana class its own shield thing. So in other words, those classes, the apple and banana, inherit off of the fruit class and essentially take what the fruit has, but can also add on and, like you, grow into your own person that's different from your parents. That's the best I can explain it in a very quick thing here. I probably just saved a lot of you an entire course that costs a couple $1,000s at college, so thank me for that later. But seriously, it's really easy to understand. I may not have explained it the best. There's plenty of other tutorials out there about how inheritance works, and it's something that I recommend everyone use when they're trying to create varieties of things in your games, whether it's enemies, whether it's players, whatever it is. Inheritance can save you a lot of time. Alright guys, so I actually have a video loaded up here, and for those of you who stayed after the inheritance speech, congratulations, I'm your new professor. No, I'm just kidding. But for those of you who just skipped ahead here, yeah, I'm just going to kind of react to this. As you can see, I have over 2 hours of footage of me just trying to code. This is specifically the ninja class in our game. That kind of comes off of the obstacle behavior, which is our main obstacle class. And essentially what it does is it's the backbone of our ninja enemy. I'll probably throw some footage right now and show you what the ninja looks like. But essentially what the ninja is supposed to do is he or she, we don't know who they are. It's kind of mysterious. they are able to teleport as they're running towards the player. So the player needs to know, do I jump, do I duck, do I just stay still and maybe they'll teleport up. It's a cool mind game, and that's something that all the regular enemies are just gonna come across the screen and get to the end. Whereas with these ninjas, you don't know what they're gonna do. Are they going to teleport? Are they gonna not teleport? You know, they can teleport multiple times, and the rate at which they teleport also has to be able to be controlled. So that's why we made the ninja class, and pretty much it's just a way to take the obstacle behavior and mold it into something specific. And we're doing this for a lot of our different enemies. You'll see me talk about that in a bit. So yeah, let me just find some interesting stuff here and maybe I can react to it. So one of the things about working with this ninja is that we wanted it to run on the ceiling. So that requires you to mess with physics. So here's me trying to like mess with that at first, and I'm like, hey, let me test out some stuff. And just like that, everything just goes crazy. Yeah, I kind of broke it, and that's pretty much where that ended. At that point, I was like, okay, let me take a break and figure out physics, because if I don't, this is going to continue to happen. And that was actually one of my favorite parts about this, though. You get to see crazy stuff like this only in game development, nowhere else. So here we're working on our dragon enemy in the game. Pretty cool stuff. You know, those ancient dragon type things that they usually have at our inspiration was from Crash Bandicoot, the China level. I know that this is Fuel Japan, but they do have dragons in Japan, so don't get too mad at us. But it was pretty cool, and these dragons, they're gonna just fly across. But as you can see, they're really like giant enemies. They're enemies that you're gonna have to either hang or duck under and kind of risk and manage your resources of your meters, which we haven't talked too much about yet, but I promise those will be in a future devlog. I'll talk all about them. But these dragons are very big enemies, so because of that, we had to make sure that when they touch the outside of the player, so like in other words, after they pass the player, we have to despawn the enemies, because we don't want a bunch of enemies just flooding the entire game world. So with these guys, we had to make sure, hey, don't despawn them until the end of them gets past there. So our solution, at least in my opinion, what I decided to do was I was like, hey, why don't I just put a collider on the end of the dragon? And that way, when his tail touches the end, then bam, he's going to all disappear, because at that point, player's not going to see any of that. They don't really care. And then at that point is when you're going to get your points awarded, because it kind of calculates your points when the enemy actually gets despawned over there. So pretty cool stuff. And it was a nice workaround, but it did take a bit of tinkering, because you have to learn about a lot with colliders and make sure that the tail isn't like a second collider that's hitting the player. It's a lot of technical stuff, I'm not gonna lie. But the dragon enemy is really cool. There are going to be many twists and turns with this one, and just be sure to manage your resources when going up against them, because if you don't, you may get damaged. But yeah, that's going to do it for this video today, guys. I hope you enjoyed this devlog, and of course, we will continue to do more. If you want to see more pre-recorded stuff, maybe I can post these, like, not full videos, but maybe an edited version, like a montage at the end of this or something. Again, feedback is totally welcome to these devlogs. I don't want to make them too long, because I understand people have other things to do. But at the same time, I want to be able to give you guys a lot of insight on just game dev in general and learning about Unity and whatnot. So I won't keep you guys too much longer. I did just want to mention real quick, this shirt, the Caution Slippery One Wet shirt, is available on our merch store, so you can buy that. It's based on the Life's a Drag game, one of the levels in there. So if you played the game, you probably know, and obviously it's a bit of a funny shirt because of that. So with that being said, I'm gonna end it right here, guys. Hope you guys enjoyed this devlog. I'll catch you in the next one. I've been RZ, and remember, over here at Bukugames, if it's not fun, it's not worth it.